I have several experiments where this material is the strongest between all fiber reinforced polycarbonates I ever tested so far. Hello, welcome to my tech farm. I have some polycarbonate filaments on the test. This is AddNorth PC Blend HT LCF. And the first spool I bought myself, and the second spool was sent to me by the AddNorth. They sent me some nylon filaments too in a separate video, and they also included the polycarbonate, so that's why I have two filaments. But this is not a sponsored video by AddNorth, so there is no additional payment. But this video and actually whole channel is sponsored by Polymaker, and from them I even have the budget to buy any filament I want to test. Let's see a few specifications from the website. This is PC PBT blend. With this, the printability is improved and also some mechanical properties. HT means high temperature, and according to them, heat resistance up to 185 degrees Celsius, which is really huge, but of course it will be tested in this video. LCF, long carbon fibers, but of course these are shop carbon fibers, and probably longer than typical, but they claim that 0.4 mm nozzle is still enough. Excellent mechanical and thermal properties. Thermal properties already mentioned. Now they don't mention detailedly which mechanical properties. Usually fibers helps with the rigidity, it resists better to the bending, but usually adding fibers will result a more brittle filament or the object. This means the impact resistance is lower. But as I mentioned, this will be also tested in this video. Unlike most of the PC blends, they claim this is completely styrene free. This means less harmful odor during the printing. Print settings: nozzle temperature between 265 and 290 degrees Celsius, bed between 100 and 120 degrees Celsius, and already mentioned 0.4 mm nozzle is enough according to their specifications. And of course, adding fibers means we have better dimensional stability, less shrinking. This means better printability. But it's time to see what's in the box. Sticker on the box is a little bit different, but let's see what's inside. The inner packaging is equal. I can see the same sticker, only this is vacuum packaging and this one not, but probably this was vacuum packaging too, only I think the air leaked in. Let's open this one. Looks like the bag is resealable on the longer side. Desiccant, and this is half kilogram spool. Later I noticed now they have only 1 kilogram spools. That's why I showed specifications on the reseller website. Let's see how brittle is the filament. Not too brittle, but let's measure it. Start angle at 25 degrees. Approximately 90. This is moderately brittle. On the AddNorth website, they offer profiles for different printers, including H2D, so I downloaded this configuration file. After unzipping, I can import it into Bamboo Studio. Import, configurations, searching for this file. Already installed, so I just overwrite it. And then we can find it in the list. Let's see those settings. Chamber temperature 50 degrees Celsius, bed 70 engineering plate and 285 on the nozzle. 15 will be the maximal flow. Let's see the part cooling, 40% fixed. I think 2 seconds minimal layer printing time is too short, so I like to increase this value. Oozing check. Okay, not so big, so I'll try to print with this filament. The start is good, and I hope that 70 degrees Celsius on the bed will be enough. Engineering plate with the glue on it. Printing is finished a few seconds ago. Definitely I would use more than 70 degrees Celsius. It's fine, but I think it needs more. Few more test objects for my future testing videos. A hook clamp. And these test objects will be used for 7 PCCF comparison video, because this filament will be included too. For comparison, I want to use the average value for fiber reinforced PET, and I have 11 in that pattern summary table. Soon I want to make a video to compare better these two material types. Tensile test with horizontally printed objects. Quite strong. This is fantastic tensile strength, not only compared to the average PET-CF, but almost to any other filament type. Layer adhesion vertically printed. This is good too. According to my rating, this is a great layer adhesion. Now we can see that this average PET-CF is a little bit better compared to this PCCF, but basically only two filaments from Chidi deforms this, otherwise it will be very similar, but as I mentioned in both cases, this is great layer adhesion. Shear test, starting with vertically printed, horizontally printed with stronger crank scale, printed in horizontal position. Fibers always helps here a lot, and we can see small advantage compared to the average PET-CF, and basically only some special nylons are stronger than this PCCF. Printed in vertical position, a small advantage on the PET-CF side, but this is good value too from PCCF. Torsion test. I'm starting with horizontal one. This is the load at 90-degree rotation. And after almost one turn, this is the maximal load. Printed in vertical position, the maximal load 1.7. As always, similar numbers but different break type. Printed in horizontal position, load in 90-degree rotation, and this is the vertically printed maximal load. And this is typical that we can see similar numbers, of course different break type. Compared to the average PET-CF, this is very similar value. Here, very small advantage on the PCCF side compared to the average PET-CF. 3-point bending test. Distance between supports is 50 mm. And I'm placing these loads and I'm measuring the deformation after 1, 30 and 60 seconds. Currently under 10 kilograms and no additional deformation during this 1 minute. Now this one is interesting. Not only that we can see smaller deformation on this PCCF, but look at this. Under 10 kilograms, absolutely no additional deformation during that 1 minute. This is extremely rare situation. Another bending test in my universal testing machine. Distance between supports is 64 mm, and this is real-time speed. It breaks very suddenly. You can see here the graph and the maximal load, bending strength and elastic modulus. This is a relatively new test for me on this channel, and I have only 4 any fiber reinforced filament in that summary table, and it will be used in this comparison. And we can see that this PCCF is extremely strong, both bending strength and elastic modulus. Impact test, and I'm starting with the Sharpie standard. And in the first measuring I forgot to switch the method. I was measuring in a lost mode, so I only have the angle, but only this means more job for me. I have to calculate the breaking energy. ISO test. And here I have these 3 measurings. ISO, and this is for the Sharpie test, and here I have only one filament, that's Polymaker PET-GF. But if you compare these small advantages on the PET-CF side, but the difference is not big, and these are relatively brittle materials. Yes, tougher than PETG, but more brittle compared to no fiber versions. Creep test, the deformation under constant load of 1.25 kilograms. 1262. So this is the initial deformation, and now let's jump 5 days. Day 5, the last measuring. 12.73. Let's remove the load. On this graph we can see the distance between 2 reference surfaces, and we can see significantly smaller deformation on this AddNorth PCCF compared to the average PET-CF. Creeping is the difference between 2 days, and that's presented here. In both cases this creeping is very minimal, but of course smaller on this PCCF. Temperature test in the oven, and this is the filament from this video. And as always I have several tests in the progress, and most of them deformed much earlier, so I have to take them out. And I continue with the testing with this AddNorth PCCF filament. and only at approximately 200 degrees Celsius it started with the deformation, which is huge, very good for PCCF filament. On 230 I stopped the experiment. Of course, at this point it was completely deformed and flexible. This is extremely good temperature resistance, which is not really typical for PCCF filaments. Yes, they are more heat resistant compared to the average PETCF, but exactly this filament is almost in the range of some nylons. All results one more time: creep test, tensile test and a layer adhesion, shear test, horizontal and vertical, bending test, deformation after 30 seconds, bending test, deformation under these loads after 1, 30 and 60 seconds, torsion test, horizontal and vertical, impact test, ISO and Sharpie, temperature test, and that new bending test. Well, definitely very strong, but also expensive material. This temperature resistance is incredible, almost in the range of the nylons, only we don't have that creeping here, unlike with the nylon filaments. And definitely I will include this material into that comparison video, where I will compare directly against each other 7 PCCF filaments. And I hope you will follow me to that video too. Thanks to the Polymaker for sponsoring the channel, and to all my Patreon supporters, and to all you others, thank you for watching with this video till the end, and happy printing!